In this video, we are going to learn that how we are going to solve the first order differential equation using the separable method. And the equation is given in the form of this one, that there will be some function m of x, y. M is a function depending on x and y, and n also depending on x and y, and there will be the first derivative dy by dx equals to 0. But we are going to transform the equation in the form as that m will be only depending on x variable and the function n will be only depending on y variable. Multiply by dy by dx equals to 0. Further, we can just simplify them, that we will keep the dy with n function and we will take this dx with the m. Okay, so mx dx and ny dy equals to 0. First, we are going to separate them, and then we are going to integrate them with respect to x and y respectively. So the first question we can solve using the separable method. Solve the following differential equation, which is given as this: y dash equals to 3x square minus 1 over 3 plus 2y. How to solve then? First, we are going to rewrite the given equation as that we will take this y on this side and the other function we will keep on the same side, right hand side. So dy by dx equals to 3x minus 1 and 3 plus 2y. And after that we will just separate them, and this will be with dy and x variables will be with dx. So it is called the separable equation because we have separated the x and y functions. So integrate the left hand side with respect to y and right hand side with respect to x, and when we integrate we will get here 3 integral with respect to y is 3y, and this becomes 2y square over 2, so 2 will be cancelled, and this becomes 3x cube over 3, and this becomes x plus the constant of integration. So this will be the solution of the given differential equation using the separable method. Okay, and next we can solve again also another question, and we have to, for this is the initial value problem. The initial conditions are given that y of 0 equals to 1, and we have to write down the solution now in explicit form. Okay, in explicit form means that we have to rearrange the solution in terms of y, in terms of x, okay, in the last when we get the solution. So first step is same, that we will just write down dy by dx because this is first derivative, and take the dx with the x functions and y variables we are going to take with dy. So just rearrange the equation, that on one side will be y and the function of y with dy, and on the other side will be the function having the x values and with the dx. So this is called the separable equation, and then we are going to integrate with respect to y and x respectively, and we will get the answer equals to 3y plus 2y square equals to minus e power minus x minus e power x plus c. Now we have to find, this is not the explicit function because it is having the y square, so we have to remove this y. Okay, so we can do it by completing square method also, or first we will apply the initial conditions, okay, so that we can get the value of c, the constant of integration. The initial conditions are given: y of 0 equals to 1, where y is 1 and x is 0. Okay, so we just substitute in the given equation and the solution equation, and we will get c equals to 7. So substitute this c equals to 7 in this equation number 1, with, and we will get the 3y plus 2y square equals to minus e power minus x minus e power x plus 7. So this is actually the implicit solution, that we have not expressed y in terms of x. Okay, so there is some y square, so we need here just the y term or the y variable. Now we are for finding the explicit form of the solution. Now we are going to take, we can make the complete square, or we can use the complete square method here, that we will take this whatever the coefficient of y is, we will divide it by 2, and then we will take the square of that function. Okay, so we divide the 3 by 2 and then we take the square of that function. Or first we will just remove this 2, so we will divide every term by 2 so that we can get here just y square. Okay, and after that we are going to, now this is the coefficient of y, we will divide with 2, so it becomes 3 over 4, and then take the square of that 3 over 4. 3 over square 4 square is 9 over 16, so one time we are going to add and one time we are going to subtract that function, okay, or that term. So it will become a complete square on this side. So we will take this now, the plus sign 9 over 16, so it becomes y plus 3 over 4 whole square. So the terms, first three terms becomes the complete square of this y plus 3 over 4 whole square minus 9 over 16, and on this side it is same. Okay, now this term we can take it to the other side. Okay, so this becomes plus minus, on this side it becomes just plus, because on this side it was minus. So here this should not be there, so we have to remove this negative sign. And after that we will see, just we are going to rearrange them, so and simplify them. So this becomes like, first we are going to take 16 as an LCM, so we can just multiply this with the 8, each of the term with 8, and here will be the plus sign, so just remove this minus sign here, so it becomes plus 9. So 56 plus 9 will be 65. Okay, so this will be, and take the square root of both sides so that we can remove this square. So we will get y plus 3 over 4, and on this side with the plus and minus sign take the square root of this side also, and then we are going to uh, we can take this 16 out of the square root, so it is 1 over 4, so you just can take it out, and just this we can take it to this side, so it becomes negative 3 over 4, and plus minus 1 over 4, and minus 8 into e power minus x minus 8 e power x plus 16 square root. So now we can see that we can get y in terms of, on this side are all the x terms or the constants. So this is called the explicit solution. Okay, so this is how we can get the explicit solution of the given differential equation. And we can check our answer also if you want to check that our solution, which now here we are having two solutions, one with the plus sign and the other with the negative sign. So we can check by substituting the initial values, like y of 0 equals to 1, that y is 1 and x is 0. So we can substitute one time with the plus term and the other solution with a negative, so that is y1 and y2. So substitute this value, initial conditions, in each of the solution, so whatever the solution is satisfied. Now we can see here, here we get on both sides 1 equals to 1, but on this side we get the term which is having negative, it was not equal, so they are different on both sides, right hand side and left hand side. So we conclude that y1 is the solution of the given initial value problem. So like this we have to do in the end, that which solution is correct if there are coming two solutions. So we have to apply the initial conditions and we have to check which condition is satisfied by the which solution. So that will be the solution of the given differential equation. So this is how we are going to solve the separable differential equation using the separable method. Or if they have asked you to find the explicit solution or the initial values are given, then we have to find the value of c, and then we are going to find the solution. So this is all. Thank you for joining.